recall that that gives us a way to check our work when we were solving equations back earlier in the year. Right? Either the answer you came up with makes the equation true, which means it's actually the solution, or it doesn't. Right? And you've done something wrong or have an error somewhere. So, what does it mean to get a system of equations? Well, like I just said on that first page here, it means it's two or more equations that use the same variable. Two or more equations that use the same variables makes a system of equations. Now, what does it mean to be a solution to a system of equations? Well, we just highlighted that by showing the graphing technique. Right? What we were looking for when we solved by graphing was where the two lines that one each represented an equation, where they intersect. What we're really looking for is the ordered pair of x, y values that make both, which you make that all caps, make both equations true. But the solution to a system is the ordered pair of the x and y values that make both equations true. Right. Now, before we start on a specific example, we also want to kind of go over here in the background. It's important for us to keep in mind this overall concept for systems can be solved for us in three ways. Again, you need to be writing this on your note sheets. Right? The first method was graphing, which we covered last time. Today we will be talking about a method called substitution. And the third method we will get to here in a few days. It's called elimination. But we'll be talking about that even as we start solving systems. Keep in mind, for us in Algebra 1, there's going to be three techniques we use. There's more than these three, but for Algebra 1, we're going to use these three techniques: graphing, substitution, elimination. Now, let's talk specifically about the substitution method. Okay? Now, it works best when one of your equations has, or you can get, a variable alone. If you look up here at this example we're going to do here in a couple minutes, you'll notice that x isn't alone in the first equation. Y isn't alone in the first equation. X isn't alone in the second equation. 3y isn't alone in the second equation. Now, that doesn't mean it's not one x. I mean, but the variable isn't by itself. Substitution works best when one of your equations has, which it doesn't over here, or you can get, which is what we're going to have to do. We're going to have to get one of the variables. Right? But our first step is going to be to get a variable alone. So, we need to be writing alone. We need to get a variable alone in one of your equations. The second thing we want to do is we want to go to the other equation and substitute. That's why the method is called substitution. We want to substitute in what that variable is equal to in the first equation. And again, these will be more as we go through it, but I did want to talk about the steps today. Now, step 3. Now you have an equation with only one variable. That's important, right? We have two variables. The answer looks like a line. It requires two values. Now, one variable, the answer can be a number. All right, step 4, we want to solve that equation. Step 5, we want to take that value and substitute it in one of the original equations, or one of the one of the equations we made. One of the equations we made. One of the equations we made. And our last step is to solve that equation. class.